Question 5. So for part A, so first things first, make sure you realise that this really just comprises sec3y times sec3y, because this is just sec3y all squared. Then just treat it as two things being multiplied together that needs to be differentiated, so we use the product rule. So working out dx dy, we've got u being sec3y, but also v being sec3y. We differentiate with reference to the formulae which we are given. We know that the differential of sec x is sec x tan x. So the differential is sec3y, just a little bit more to take into account. Remember, we've got to take into account the differentiating the function itself. So differential of, so du dy is 3 lots of sec3y tan 3y, because there's the 3. And of course this is repeated with v, which is just a repeat. So so this gives us so following the product rule, so u times dv dy plus v times du dy gives us this, which is just 2 lots of the first and the second term, so 6 lots of sec squared 3y tan 3y. Now for part B, we've got to show this. So our starting off point, we can just inverse our dx dy to get our dy dx. Now we need to get this in terms of x, so we need to bear in mind all the time we really need to be manipulating this to be left with lots of sec squared 3y, because the second we've got it in terms of sec squared 3y, we can then turn it back to x. So we're okay with this first part of the denominator, because obviously sec squared 3y is already an x, so we know we're going to be getting an x here. Our problem is this tan 3y. Now we need to be able to work out, or you've learnt, that tan 3y is the same thing as the square root of sec squared 3y minus 1. I've shown this up here as working 1, starting off with the C2 formula, sin squared theta plus cos squared theta equals 1. If you divide both all the terms by cos squared theta, you get this. Sin squared over cos squared is obviously tan squared, 1 over cos squared is sec squared, so we get this. And then just to get it in terms of tan alone, take away 1 and square root gives us this. So probably the biggest step of this question is to appreciate that. That can then be substituted in place of our tan 3y. We're now ready to go because all of this is in terms of sec squared 3y. So we can just substitute in for x, and that gives us what we were looking for. Now for part C, we've got to take a second differential, so we need to differentiate this. This is a division, so we use the quotient rule. U is 1, v is the denominator. Du dx is 0, so that means that when we do our v du dx minus u dv dx all over v squared, that our first term on the numerator doesn't exist. And so our numerator fully comprises the second bit, so not the v du dx, but the minusing u dv dx. U is 1, so it's all about the dv dx. Now this dv dx I've worked out over here. Okay, to work out our dv dx, we need to do another product rule on v. So I've done that over here. So that's all over v squared. So we get this. Now you would be pretty much picking up most marks at this point, but it does ask for our answer in its simplest form. If you get too bogged down with this bit in red, I wouldn't overly worry. We're only talking 1 or 2 marks. Now the key to success here is to choose to multiply top and bottom by x minus 1 to the power of a half. That really eliminates a lot of the stuff in the numerator. Giving us this. This is our denominator. The numerator sort of cancels right down to just 2 minus 3x all over this denominator. So have a go at this bit in red, but if you get lost on that, I would just move on. There probably a couple of marks you can afford to drop.